Hi everyone. In this video, I'm going to explain about dynamic knapsack. So today we are discussing about one more different type of problem called knapsack problem. So what do you mean by this knapsack problem? In general English meaning, knapsack means some container. That's it, container called some carry bag or some cover, whatever. So some carry bag, whatever called that container in general you call as knapsack. Knapsack means in simple words what? Some carry bag or some container which is used to hold some items. Let us take some, this is some knapsack. It is having some capacity. Let us take this having some capacity. Let us take some 10 kg. There is maximum capacity of m kg. That means this knapsack or this container can hold the item of some maximum of this m kg. And in this problem, there will be some n number of items. Okay, there will be some n number of items. So that items may be anything. Okay, there are n number of items or objects or elements or whatever you can call. And there will be some, when I say any object, if I say this is a pen, or if I take a mobile, or if I take sheets, or whatever, every object has its own some weight, right? So Wi is the weight of the object. That means every object is having some weight, that will call as a Wi, and every object is having some profit. That means if I take this, I'll get some profit. That means every object is having some value. So that will call as a profit I. Okay. And we have some knapsack. That knapsack is having some maximum capacity of m kg. Now what we need to do is, out of this n number of items, we need to select the few items in such a way that we should get maximum profit. Okay, we should get what? Maximum profit. This is the first condition. That means out of this n number of items, we need to select the items in such a way that I should get maximum profit. And second condition is that the total weight of the selected items, okay, the total weight of the selected items should be what? Less than or equal to our knapsack capacity. How much capacity we are having? Only that much elements only I am to select. Assume for example, say x1, x2, x3, x4, x5. Some 6 elements are there, 6 items are there. Out of these 6 elements, suppose for example, assume I selected x2, I selected x4 and I selected x5. I selected these 3 items. So the total weight of these 3 items should be less than or equal to the knapsack capacity. Okay, so this is what the problem definition and this problem constraints. Okay, so objective of this problem is to obtain what? Maximum profit. This is what knapsack problem. So in order to solve this knapsack problem, we are applying dynamic programming technique. Hence this is called dynamic knapsack. Okay, hence it's called dynamic knapsack. And in this problem, we need to select the complete item. Okay, so it is not possible to take fraction. Okay, we either take complete item to take, or we should not take that. Okay, so it is not allowed to take part of the item, or it is not allowed to take fraction of the item or some part of it. For example, if it is not possible to take the complete, I will take only the pen cap. No, if you want to take, you take complete pen. Otherwise, you should not take. Okay. Similarly, suppose if any item is having some 10 kg item, so that 10 kg item completely we need to take. We cannot take only 3 kg or take out of 10 kg. No, not like that. So whenever we are selecting, we need to select that item what? Complete item. That means one, full. Otherwise, I need to take, not take. That means either nil or full item you take. So hence this dynamic knapsack is also called as 0-1 knapsack. Okay, 0-1 knapsack. Since this is 0-1 is binary, this dynamic knapsack is also called as binary knapsack. So, okay, so binary knapsack, 0-1 knapsack, dynamic knapsack, all are same. So now what we know, I hope you people understood what do you mean by knapsack problem, what we need to do, and now what do you mean by dynamic knapsack, which is also called as 0-1 knapsack, binary knapsack. Along with these terminologies, now I will use 2 more. One is called I. This indicates ith item in question. Okay, ith item in question. That means I indicates which is the item in question, that is whether I need to select or not. Okay, one more is called J. It indicates remaining capacity of the knapsack. Remaining capacity of the knapsack. For example, assume already I selected some items into my knapsack. Out of mkg, assume it is already occupied some kg, and this is my remaining capacity. Let us take that 2 kg is remaining. Assume 2 kg is remaining capacity in the knapsack. Now assume already I selected x2, x4, x5 already selected, and now assume there are two more items left out. Two more items are left out, x6, x7, and assume x6 weight is also 2 kg and x7 is also 2 kg. Okay, so now assume now the weight of this sixth item, weight of the seventh item, both are 2 kg, and profit of this item is say 20 rupees and profit of this is say 25 rupees. Okay, for example, okay, weight of the sixth item is 2 kg, weight of the seventh item is 2 kg, both are same. Profit of sixth item is 20, profit of seventh item is 25. Now in my knapsack, how much capacity is remaining? 2 kg is remaining. So can we take this item or not? Yes. Now this is my what? This is the item now in question. I already checked all these things. I selected this. I not selected these two. I selected these three. Now this is the item in question, sixth item. Now can I take it or not? That's what can I take it or not? Now if you observe this example, can we take it or not? Yes, we can take. Why? Weight of this object is 2 kg and remaining is also 2 kg. Yes, aramse I can fill. But if I take this, I can fit, but I won't get the maximum profit because the value of this item is less when compared to the value of this one. So now by excluding this and by including this, that means by leaving this, by including this, I will get the maximum profit. If I select this, I won't get the maximum profit. I will get loss by 5 rupees. Okay, this is what the item in question. So now hope you people understood what is my I. Okay, J indicates remaining capacity. So now with this, now we will discuss 3 formula which is going to be used to solve this problem. Now case 1, assume if I is equal to 0. If I is equal to means what? I is what? Item. That means item only, not there. I is equal to 0, item is not there. Assume thief went to the house with some knapsack capacity. But assume there is no items only in the house. There is no valuable items. What is the profit you get? 0. That means if the item is not there, if there is no valuable item, I is equal to 0, that means there is no item. What is the value I will get? Value I will get if I select this ith item with this remaining capacity. That means what is the value I will get by selecting this ith item with this remaining capacity. Since there is no item only, I is 0, I will get value 0. Okay, and that means I is equal to 0 indicates what? No item. Similarly, if J is equal to 0, assume thief went to some house. In that house, there are some valuable items are there, but in the hurry or in the urgent, so the thief has forget to carry the knapsack, that is some carry bag to bring the things. Okay, at that time, where he will keep? So it was not possible to keep the items. So in this case, the item is there. Assume item is there, but there is no knapsack capacity because J is equal to 0. No knapsack capacity also means what? Again, value is 0. That means in this case, any one is 0. If I is 0 or J is 0, value what we got is 0. Okay. That means if there is no knapsack capacity, or if no item, in both cases, what is the value I got? Value I got is 0. Similarly, let us say second case. What is the value I am getting? Assume now in this case, some item is there, some capacity is also there. Now what I have to do? Now I need to check. For example, assume take the same example. What is the remaining capacity in this one? 2 kg is remaining in our knapsack. Now assume weight of this item is 3 kg. Can I take this item? Now this is the item in question. This is the ith item in the question. Now is it possible to take this ith item? No. Why? Because weight of this object is 3 kg, but we have left out with what? Only 2 kg. So there is not possible to take this one. So because either we will take full item or nil item. So it is not possible. So at that time I have to leave this item. Leave this item means I have to subtract this. That means I have to left. So earlier before deciding we have 2 items. Now this item cannot be taken. So remaining how much? 1. That means 2 minus 1. That is minus 1. That means if this item I am not taking means I have to minus 1. That means value what? See, this item I am not taking means either I will get any value. No, I will get the same value V. Okay. Since this item I am leaving, I am writing I minus 1. Okay. Since this item I am not taking, remaining capacity remains same or change. Assume if I include this, it has to change. But since I'm not taking, remaining capacity 2 kg remains as it is. So J remain as it is. Okay. This in which case, if weight of the object, see weight of this object is what? Greater than the remaining capacity. So weight of the object is greater than the remaining capacity. Or I can say, see remaining capacity is 2 kg, less than the weight of this object. Remaining capacity less than weight of this object. So remaining capacity J less than weight of the object. In both this case, I have to leave that object I minus 1, but remaining capacities remain same. This is the case 2. Okay. Now last one, case 3. So now assume there is, let us take now it is 3 kg is left. Assume 3 kg is left. This is 3 kg and this is 2 kg item. This is 20 rupees. This is 25 rupees. Now there is some items are there. These 2 items are there. Okay. And remaining capacity is also there. Now in this case, now assume now weight of this object is how much? 3 kg. Or remaining capacity is 3 kg. So can I take it? Yes, I can take it. So what? So in this case, now remaining capacity weight of the object is what? Weight of the object is less than or equal to the remaining capacity. Okay. Or same thing, remaining capacity is greater than or equal to the weight of the object. So in both the case, I can take the object. If I take the object, now I need to check. See, observe closely now. If I take this object, I will get the maximum profit. See, if I take this, I cannot take this. Now, assume if I take this, I cannot take this. In that case, what is the profit added? 20 rupees added to this profit. Suppose assume I have not added this one. By leaving this, if I include this, how much of profit will be added? 25. That means which one is more profitable? 7th item is profitable. But now this is the item in question. Whether I need to select this or by if I select this means I have to leave this. That means I have to include this by excluding this, or by including this. Which one gives us the maximum profit? That I need to check. So whichever gives the maximum value. So I will take maximum of. Okay, so now whichever. So leaving means what? I minus 1. Okay, leaving. If I leave this means what? I minus 1. So then if I leave this object, I'm not including. Remaining capacity remains same or what? Yes, it remains same, J. Now this is indicates what? This is by excluding. If I excluding, I will get maximum profit, or including. Including means what? If I include this also, now out of 2 element, 1 I include, remaining element is what? 1. So again I minus 1. Since I am including this object, remaining capacity remains same or not? No. When I include this, remaining capacity becomes 0. How? The remaining capacity minus this object. Okay, so J minus what? Weight of the object. Plus, since I'm including this, its profit I will get, right? So PI. Okay, so this is the third equation. Okay, so now totally I will write consolidate. So here written the 3 cases separately explained. Now I have written at once. So this is the equation. If you understood this equation, then easily we can solve any of the problem. Okay. So in your exam, you may expect, compulsory can expect a question on this topic, either the problem or the the algorithm. See, both for both writing algorithm also, if you know these three, it's very simple. If you know these three formulas, solving the problems also easy. Hope you people know this formula. Now let us take one simple example and solve that. Let us take very simple problem. Given there are three number of items. N is number of items. Three items. Item 1, item 2, item 3. Item 1 weight is 2 kg. Item 1 profit is 3 rupees. Item 2 is 3 kg. Item 2 is profit 4 rupees. Item 3 is 4 kg. Item 3 weight profit is 5 rupees. So the given M, capital M, that is nothing but the knapsack capacity. That means knapsack capacity. That means our carry bag. Our container can hold maximum of 5 kg. Now for this, now we need to find out if I take which items, so it will get the maximum profit subjected to this condition. That means the total weight of the selected items should be less than or equal to maximum capacity. So these two conditions we need to satisfy. So for that, I told the dynamic programming solves the problem by constructing the table. Okay, so now whenever the sub problem comes, we are solving it first time, and the same sub problem comes once again, we are, instead of recalculating, simply we are getting its solution which we solved previously. So now table means how many rows, how many columns. In general, we should take some n plus 1. How many number of items? N. That n plus 1 number of rows, and capital, that means maximum knapsack asset, M plus 1 number of columns. Any problem, in general, we have to take n plus 1 number of rows. How many number of items are there? Plus 1 number of rows. What is the maximum knapsack capacity? Plus 1 number of column. This much we need to take. Okay. So now let us start solving this problem. See, this is my profit table. It should contain how many rows? N plus 1, here number of items given 3, 3 plus 1, 4 rows. Okay, row 1, row 2, row 3. Okay, so and then we are given maximum capacity 5 kg. So 5 plus 1 number of columns. So 0 to 5, so 6 columns, totally 6 columns. And this is my profit table, capital V. Okay, this is what we have done, V of I comma j. Okay, that we are writing. Okay, so now according to the equation, what we know that if I is equal to 0 or j is equal to 0, value is 0. So here where I is equal to 0, see, I is equal to 0. See, now row is what? Number of items. I is ith item. So here I is running from what? I is running from 0 to 3. And since this is the J is M, that is M is number of M is the remaining capacity column, M plus 1 column. So J is running from what? 0 to capital M. M is what? Maximum Fi. And number of items N is equal to 3. Okay. So I will run from 0 to N. So now if I is equal to 0, I is equal to 0 means this row. So all or this entry will be 0. And j is equal to 0, this column will be 0. Okay. This is common for all the problems. Whichever the problem, first construct n plus 1 number of rows, m plus 1 number of columns. Then fill the first row 0th row with 0, j column as 0, because as a formula value of I comma j is equal to 0 if I is equal to 0 or j is equal to 0. This is done. Now I need to find what? This cell. What is that cell? This cell is what? V of 1 comma 1. So what is V of 1 comma 1? So always whenever take V of 1 comma 1, in I place what is there? J, I plus 1, j plus 1. That means I is equal to 1, j is equal to 1. So now always compare what? Weight of the object and the remaining capacity. That only we need to compare, because see, based on this equation only now, whether I have to use this equation or this equation, I have to find out by comparing whether this is greater or lesser equal. So based on that only, so I written Wij one side. I value is what? 1. So W1, j value is what? 1. W1 is what? Weight of the first object. Weight of the first object is what? In first object is 2 kg. So 2 and 1. 2 is greater than 1. That means weight of the object is what? Greater than j. Weight of the object is greater than j. So if weight of the object is greater than j, then what you have to find? We have to use the formula V of I minus 1 comma j. So V of I comma j is equal to v of I minus 1 comma j. This is the formula we have to use. So replace the value of I and j. That's it. 1 comma 1 is equal to value of 1 minus 1 comma 1. So this is nothing but value of 0 comma 1. V of 0 comma 1 already we calculated. V of 0 comma 1 is 0 already calculated. So simply I am writing 0. That means I got V of 1 comma 1 0. So V of 1 comma 1 is 0 I got. Next, similarly, I need to find out what? V of 1 comma 2. So V of 1 comma 2 I need to find out. In this is the I value, this is the j value. Okay. So I value is 1, j value is 2. I value is 1, j value is 2. So again, Wi and j. Wi, W1, j value 2, W1. Weight of the first object is what? 2 kg. This is 2, j value is 2, these two are equal. That means Wi is equal to j. Wi is equal to j. So that means this formula. Weight of the object is equal to j means I need to use this formula. So V of I comma j is equal to maximum of. So initially if you write the complete formula, then it is easy for you to remember. It becomes practice. Done. Now simply replace its values. Okay, V of I is 1, j value 2, maximum of value of I 1 minus 1, j value 2, V of I 1 minus 1, j is 2, weight of the I value is weight of the item is 2 plus profit of I is what? I is equal to 1. Profit of first item is what? Profit of first item is what? 3. So plus 3. So this is nothing but maximum of V of 0 comma 2, V of 0 comma 0 plus 3. So maximum of V of 0 comma 2. 0 comma 2 already we calculated. 0 comma 2. 0 comma 2 is what? 0. So this is 0. 0 comma 0 is what? Again 0 comma 0, 0. 0 plus 3, 3, which is maximum 3. So V of 1 comma 2 is equal to 3. So I will update my table. V of 1 comma 2 is 3. I will update the table 3. Okay. Similarly, I need to find all this one. Okay. So let us find out now this one. That is V of what? 1 comma 3. So that is V of 1 comma 3. I value is 1, j value is 3. That means W1 and j. W1 is what? Weight of the first object is what? Weight of the first object is 2. So 2, j is 3, 2 less than 3. That means weight of the object is less than j. If the weight of the object is less than j, weight of the object is less than j, this formula. So I return this formula. So just I replace the values of I and j here. See I, okay, 1 minus 1. So V of 0 comma 3, V of 0 comma 1 plus 3. V of 0 comma 3 already calculated. 0 comma 3 is what? 0. So it is 0 return. And V of 0 comma 1. Again V of 0 comma 1 already we calculated. No need to calculate once again. So we are replaced plus 3. So maximum of 0 comma 3. So which is maximum? 3 is maximum. So I got V of 1 comma 3. So let us update this table. So V of 1 comma 3 is what? 3. This is also 3. Okay. Similarly, now I'll calculate this. Is this what? V of 1 comma 4. So 1 comma 4, again same formula I have to use. Just I substitute the values. I will get this one maximum 0 comma 3. Again V of 1 comma 4 also I got 3. So I will update this one. Similarly, if you solve this also you will get 3. Okay. So now let us solve V of 2 comma 1. Okay, this one. So V of 2 comma 1. Here what is the value of I? I value is 2, j value is 1. So weight of the second object, okay, and j value is what? 1. Weight of the second object is what? Weight of the second object is how much? 3 kg. Weight of the second object is 3 kg. So 3 and this one. So 3 is greater than 1. That means W2 is greater than j value. So which formula have to use? Weight of the j is greater than means we have to use this formula. So V of 2 comma 1 is equal to V of 2 minus 1 comma 1. So this is nothing but V of 1 comma 1. We already calculated V of 1 comma 1. So V of 1 comma 1 is what? 0. So this is also 0. So I will update this. This is 0. I will get. Now I have to calculate what? V of 2 comma 2. V of 2 comma 2 and to calculate. Let us see V of 2 comma 3. I value is 2. J value is 3. So here weight of the 2 is what? 3 kg. Remaining capacity also 3. 3 is what? Equal. So that means weight is less than or equal to J. So which formula I have to use? I have to use this less than or equal to this formula. So directly I use this one. V of 2 comma 3 is equal to maximum of V of 2 minus 1 comma 3. Directly used. So this V of 1 comma 3, V of 1 comma 0 plus 4. Plus 4 is what? Profit. Profit of the second item object. Profit of the second object is 4. Pi formula plus Pi. Okay, I done 4. So this is nothing but maximum of V of 1 comma 3 already we calculated. V of 1 comma 3 is how much? V of 1 comma 3 is 3. V of 1 comma 3 is 3 comma V of 1 comma 0. Anyone is 0, that is 0 plus 4. Okay, so 3 4 which is maximum 4. So V of 2 comma 3 is 4. So we'll update V of 2 comma 3 as 4. So this I got only 3 only. Similarly, if you solve this one, this also will get 4. Okay. So I have read run once again just for to show simple. So here see, let us find this one value. So remaining value solve. This again one value I am solving. So this is what? V of 2 comma 5. V of 2 comma 5. So I value is 2, J value is 5. So I need to compare W2 with J. What is the weight of the second object? See, weight of the second object is 3 kg. So 3, remaining capacity J is equal to 5. So 3 is what? Less than 5. So W2 is less than J. Since less than J, so I have to use what? V of 2 comma 5 is equal to maximum of V of I minus 1 minus J. J is what? That is 5 comma V of I minus 1 J minus Wi. J is what? 5. Wi is what? That is W2 is 3 plus profit of ith item. I's value is what? 2. Okay, this is. So now this is nothing but maximum of V of 2 minus 1 1 5 comma V of 2 minus 1 1 5 minus 3 2 plus profit of second object is what? See, profit of second object is what? 4. So 4. So this is maximum of V of 1 comma 5. 1 comma 5 is what? How do we calculate 1 comma 5? 1 comma 5 is what? 1 comma 5 is 3. So V of 1 comma 5 is 3. V of 1 comma 2 already we calculated. V of 1 comma 2 is 3. 3 plus 4. So this is nothing but maximum of 3 comma 7, which is maximum 7. So V of 2 comma 5 is equal to 7. Okay. So I got this V of 2 comma 7. No, 2 comma 5 is 7. Similarly, if you solve this, you'll get this is 0. This is, you'll get 3, 4. This is 5. This is 7. This is the complete profit table. Okay, this is a complete profit table. Okay, so in order to construct this table, we have to use these 3 formulas. Hope you people understood. Now, to construct this profit table, we'll write the algorithm. So I have given the name dynamic underscore knapsack. Okay, for this problem. So parameter to be passed was what? Number of items n and weight of all the items. That means weight of the objects. You see, we given weight of all the objects is should given. Profit of all the objects should be given. So weight of 1 to n, profit of 1 to n, these two are arrays and maximum knapsack capacity. Now, whenever we are doing anything operation on any table, we have to use 2 for loops. So I will use for I is equal to 0 to what? Up to n we did. I row. Okay, row value what? From where to where we draw row value. See, from I value we did from 0 to n. Okay, j value 0 to m. So I is 0 to n. This is for the row, and for j is equal to 0 to m. Do what? Now I have to check. What to check? Simply you check these 3 conditions. That's it. Okay, you have to check if this is I is equal to 0 or j is equal to 0, then value is equal to 0. That's it. I'm checking. So if I is equal to 0 or j is equal to 0, then what is the value? Then V of I comma j is equal to what? 0. That's it. Else, suppose this is not true, both are false, then what? Then I need to check whether weight of the object is greater than or less than. So I'm checking else. If weight of the object is greater than j, if weight of the object is greater than j, then what to use? Then value of I comma j is equal to what? If weight of the object is greater than j, this one. Same thing I'm writing. Value of I minus 1 comma j. Else, assume this condition also false. I is also not 0, j is also not 0, weight of the object is not greater than, then obviously this condition. When these two condition fails, obviously this is the case. So then directly write else value of I comma j is equal to what? Maximum of value of I minus 1 j comma value of I minus 1 comma j minus wi plus pi. Okay, that's it. This is the end for finally what we need to return value table. That's it. This is the algorithm. So hope you people understood. See again, so in this formula, this is for what? This is for excluding, that means by leaving. This is by including. That means I need to check if I exclude the object, I will get the maximum profit, or including the object I will get the maximum profit. That I need to check. Okay, this is how to write the dynamic knapsack algorithm. So hope this algorithm solving the problem, so everything, that equation, all the three cases are understood. Okay. So now let us see. So from whatever the previous algorithm, from that algorithm just we generated this table. We generated only this table. But how to get the maximum profit? That means it never gives the information about which objects we selected, that value it never gives. So for that we need to write one more algorithm. So from this table, how to find out which are the items are selected? So for that what we have to do, directly come to the last row. Okay, last value is what? 7. Or come to this position. Okay, that means v of 3 comma 5, that way to come, v of 3 comma 5. Now that you compare with its above value, that means now I'm checking this item, that means now item 3 whether I have included or not. So for that you compare this value with its above value. That means what I'm comparing, value of 3 comma 5, I'm comparing with what? This one is what? V of 2 comma 5. I'm comparing V of 2 comma 5. Okay, if these two are equals means third item I'm not including. That means assume earlier when second item including also profit is 7. Now after including profit, now the item 3 also profit 7. No, if I include, the value should get changed. So since its values are not changed, that means this item I have not included. So what I will do, this item is included, so go to the previous one. Okay, since these two are equal, so this item is not included. Which one? Item 3 not included, so check item 2. That means now come to this location. Now you come to this one. Okay, this is that means v of 2 comma 5. V of 2 comma 5. Now again you compare with this above item. Okay, so above item is what? V of 1 comma 5. Now these two are equal or not equal? These two are not equal. That means earlier when this value is item 1 profit 3, when item 2 is included, profit is increased into 7. That means what? We have included that item 2. So if the values are different, it indicates ith item is included. So when item 2 is included, so earlier capacity, we are in which column? M is what? Remaining capacity, J is equal to 5. Earlier remaining capacity is equal to 5. If I include in the item 2 weight is what? Item 2 weight is 4. Item 2 weight is what? Item 2 weight is 3. Item 2 weight is 3 means 5 minus 3, 2. So since I'm including this item, I need to decrement. J remaining capacity is equal to previous remaining capacity plus weight of the object. Okay, currently remaining capacity is 5 minus weight of the ith item 2. Weight of the second item is what? Weight of the second item is 3 kg. So 5 minus 3 is equal to 2. That means J is equal to 2. Now come to the J2 column. Now I come to this column, and since this item is over, item 3 not selected, check. So now item 1. So come to the item 1. So here in this one, in this case, now that means this one. where it is intersecting in this one. Now again I'm comparing this with above value. That means value of this is what 1 comma 2. I am checking with what it's above means 0 comma 2. So since these two are equal or same, not equal. Okay, not equal means item what? Which item? Item 1. Item 1 is also selected. Item 1 also selected means what? J is equal to, it was reduced by weight of the object. So J is what? In this column 2. 2 minus weight of the object is what? 2. So J becomes 0. So when any one become I or J becomes 0, we have to stop. Okay, when J becomes 0, remaining capacity is over. So that means now item 2 is selected, item 1 is selected, item 3 is not selected. For this, I am using one solution vector called X. That X gives us the information about which item is included, which item is not included. So now we'll check. So initially what I will make, this solution vector will make it as 0. That means item 1 not included, item 2 not included, item 3 is not included. Initially was when knapsack is empty. So whenever I'm including the any object, I'm making it as 1. Okay, since item 2 is included 1, item 3 is included 1. So if this is are the 1, these other two items are included. Okay, this is the solution vector. Now for this, now we need to write the algorithm. Now I am giving the name print composition of knapsack. That means knapsack contains what and all the items that I need to print. So number of items we should get, weight of the objects, profit of the objects, value, there is profit table, this table we need to get. So this is a table, knapsack capacity. These many parameters we should get. Okay, now initially what we did, we come to the last column. That means what? I is equal to 3, J is equal to M. So in general, I is equal to N and J should be turned to M. So initialize first what? I is equal to what? N. J I initialize to what? M. So first, then in order to make all the entries of this solution vector 0, so I will use one for loop. For I is equal to 0, 1 for item 1, item 1 to N. What I will do? X of I is equal to 0. So just to initialize first 0. Okay, next what to do? So next I need to check with, see, this I compare, have to repeat as long as what? Whenever I becomes 0 or J becomes 0. So I will check while I is not equal to 0 and J is not equal to 0. That means both should have some values. That means item also should be there, remaining capacity also should, then only get value. So both should not be equal to 0. If both are not equal to 0, then I am checking what? If value of what I am comparing, if you observe, see V of 3 comma 5, I am comparing with V of 2 comma 5. Next I am comparing V of 2 comma 5 with previous 1 comma 5. See, only 5 remains same, only I value is reduced by 1. V of 1 comma 2, 1 minus 1, 0, comma, okay. So in general, V of I comma J, I am comparing with a not equal to V of its previous means I minus 1 comma J. If these two are not equal, then what? We have selected. We have selected means that entry in the solution vector have to make it as 1. So X of I need to make it as 1. Since I included, see I need to reduce its weight. Okay, so J is equal to J minus Wi. I need to reduce the remaining capacity. Okay, that's it. Okay, over end if. Okay, so then I need to decrement the I value. Okay, anyhow after this, see, first V of 3, then V of 2, then V of 1. So each time I am reduce. Okay, I minus 1. So end while. So now I am checking what? So I am checking the solution vector. Now for that, for I is equal to 1 to N. Do what? If X of I is equal to 1, then what we are printing? Then we are print what? Item I is selected. End for close. Okay, so that means if that value is equal to 1, then that item is selected. So that's what we are doing. If X of I is equal to 1, print that item I is selected. Okay, so this is the algorithm for the print composition. So okay, hope you people understood this algorithm. Thank you. Thanks for watching. If you have any questions, please write it in the comments. Thanks for watching.